Hi grade 9s, this video will help explain all the science concepts that are going to be covered this week.
Okay, so for this week, we are looking at week 7, May 11th to May 15th. So you'll notice there's not as many activities that are in this week's worth of stuff, mainly because we're focusing on two different things. So I'll probably type in those learning intentions later. We are focusing on what is a molecular compound and then how to name it, okay? So once you're done watching this video, I would strongly recommend for you to watch these two videos. So this one here goes through in way more detail what a molecular compound is and how to name it. And this one is very specific to just naming it. Again, I would watch both just to make sure the concepts are clear in your mind. PowerPoint I'll go over in a minute in this video. Then after that, you do have 2 worksheets this time to complete. Unfortunately, you'll have to do these worksheets on a separate piece of paper. Sorry, I could only find PDF versions. And then finally, I have a real-life application, which I'll explain towards the end of this video. So first, let's take a look at our PowerPoint. So 2 things that we're going to focus on is how to form a molecular compound. And the old term that they used to call it is covalent. Just so you see that coming up, it is the same thing. And then we're going to focus on how to name it. So last time, and I'm just going to flip to a different picture. Last time we talked about ionic compounds. So that's when an ion, such as sodium, delivers its electron to another ion so that one of them will lose one and one of them will gain one, and that's what creates the bond. And I love this photo here. I just think it's super cute. And I also used that reference last time about how it's like that couple that's completely inseparable, or those group of people that are always inseparable. But remember, they're giving and taking in this, okay? With molecular compounds, there's a couple key differences. Here we're talking about 2 non-metals. So in an ionic compound, it's a metal and a non-metal. In this case, they're all non-metals, okay? They're held together by covalent bonds, which is why they used to be called covalent compounds. And the big idea with this guy is they actually share electrons. They're not giving and taking. Okay, so there's a little bit more about molecular compounds for you to go over. The key thing with these guys is they're not going to pull those electrons. Instead, like I said, they're just going to share it. That way they have a full octet. So really what that looks like is what's going on here. So we talked about this where it's giving that electron. Here it's like, they're just going to share. So hydrogen, its outer shell likes 2 electrons, so it's going to share with another hydrogen. Now this one also gets 2 electrons, and this also gets 2 electrons. So both those hydrogen atoms are nice and happy. So just some examples for you to go over. Okay. Now here's the part that I want to spend a little bit of time on, and that's naming. So in ionic compounds, like we said, we always keep the first name the same and the last name changes a little bit. Here it's a tad different than that. So the first thing that we're going to need to figure out are the prefixes. There's a link in this video to another video, ironically, of what that looks like, but I'm going to show you just this part of that video. When you're looking at your prefixes, it's important to remember what they are. So we've got mono, di, tri, tetra, penta, hexa, hepta, octa, non, and deca. So really what that means is 1, 2, so on and so forth. But it's best to find a way to remember it, and I kind of like this, so I'll just quickly go over it. So 1 is mono, like monorail, right? We know mono means 1. 2 is di, like a pair of dice in this example. 3 is tri, like tricycle or triangle. 4 is tetra, so for example, the Tetris game, built up of always 4 blocks. Penta is 5, like the pentagon has 5 sides. Hexa is 6, like a hexagon. 7 is hepta, and it's true, I don't know if I have any way to remember hepta. If you guys have one, let me know. Octa, like my favorite is the octopus one, 8 arms, same deal, or in this case, the octagon. Non kind of sounds like 9, and deca, like decade or decameter. So unfortunately, unless some of you guys can figure out another way to do it, I think you just have to memorize these. So keep it on reference. While you're working through this worksheet, I would just keep either this slide up somewhere or the slide in the PowerPoint. Just keep it somewhere where you can keep referring to it. So when we're talking about naming it, we'll look at 2 different things here. So if you're looking at this example here, carbon dioxide, we're saying it's got 1 carbon molecule. And just like math, just like the week's lessons before, if it's 1, you don't actually write it, especially in the beginning of the name, you don't write monocarbon, it's just carbon. And again, it just goes back to sometimes mathematicians and scientists are lazy. So carbon is there. And then dioxide. Well, we know di means two. So that means it's got two oxygens, okay? So carbon dioxide is one carbon and two oxygens. Let's look at this one. Iodine pentafluoride. So same deal. Iodine is just like that carbon. It's just one of them. Penta, we can go back to our referencing chart. Penta is 5. So iodine, there's one iodine, 5 of fluoride, so 5 fluorine atoms. And so it looks like that. So you're looking at sulfur and 4 chlorine atoms. So the sulfur we know is just one, so you'll just write it as sulfur. Now the 4 chlorine, it's going to be tetra. And again, we got to worry about that ending. So it's going to be sulfur tetrachloride. And then for this one, it's going to be nitrogen, and there's 3 of them. So nitrogen trifluoride. Okay. Another thing to remember, and I know this is super confusing and I wish I could make this simpler, is to keep in mind a lot of these molecular compounds have what's called their chemical name. But of course, there are some with common names, right? So like dihydrogen monoxide, and remember that mono is popping on because it's talking about the second atom, which is the oxygen. We don't ever say dihydrogen monoxide. I think some of you guys might say it as a joke, but really it's water, okay, or H2O. So just things to think about when you're seeing that. So it does get a little confusing. Just do your best to kind of remember the rules that I talked about. So once you've familiarized yourself with molecular compounds and how to name it, try these worksheets. What I would recommend is going over them and doing the best you absolutely can, and then popping into our Google Meets to ask us specific questions, because some of these can be very confusing and there's a lot of things that you guys are seeing for the first time. So why don't we look at just right now silicon dioxide. So I'm asking for the formula. What that means is I'm looking for something like this, some letters and some numbers or some subscripts. So silicon, we know, is it's the first piece of the compound. So we're looking for just that element. And of course, we can see it has no prefix in the beginning, which means it's going to simply have one element of silicon. Di, if you remember, is 2, and I'm hoping you answered out loud. And then oxide is just oxygen. So it would look something like this. Let's look at this one here. So you've got 1 carbon and 4 of an F. So we know the 1 carbon is just 1. So again, normally you'd want to write mono, but because it's in the beginning, we drop that prefix. So it'll just be a carbon. And we know the F is fluorine, and there's 4 of them. So for that one, it would be carbon tetrafluoride. Remember, we changed that ending there. Another hint is while you're doing this worksheet, when you are all done, feel free to Google it. The answers come up almost right away, and you can use that tool to check your work. So second worksheet, exact same deal. I'm only asking you to name it though, as opposed to giving me the chemical formulas, okay? So work on those 2. And again, if you're stuck, pop onto any of our Google Meets. We'll be more than happy to help you. Finally, by the end of the week, what I would love for you guys to do is to look at this real life application. You should have a copy of this already in your Google Drive. Make sure you pop your name on there and what class you're in. And kind of like last time, I'm asking you to find 3 items in your home that are this time molecular compounds. You can Google it if you want. I do have examples to help you. What I've added to this week's challenge is to, of course, give me the compound. And by this, I mean formula. In fact, I'm going to change that right now. Tell me what that compound actually does, and then the name of it. Again, examples are there, and then that is what you're submitting to us. So you, again, should have a copy of this in your Google Drive. That is everything for this week. It's a little bit shorter than normal, like I said. Please, please, please don't struggle with this. We're literally online all day. Just pop in even just to ask the question, and then you can leave. We've got no problem doing that. A couple of kids often do that. So hope that helps. Hope this video helped. I know last time you guys asked for me to go in more details in those PowerPoints. I hope I did. Yeah, good luck with everything on molecular compounds. I'll see you guys later. Bye.